Okay, last video for now, because I'm physically exhausted doing this. Everything hurts. Okay, so I've hooked it up, and when I turn it on like this, I'll show you. We turn it on. She slows down. Now the ferrite motor goes up to 68 volts. Now you'll say, now an engineer would say, oh, 68 volts, well that's a 200 watt motor and 178 watts worth of batteries. So at 68 volts, all you can take is 2.3 amps, right? To make up what the system's using. But that's not right, because you can draw out of this generator, right, with the torque that it's got, right, you can take out 3.8 kilowatts, or 3,800 watts from the 200 watts you're putting in, right? So that's because that's how much torque this has got now. That's how much torque it's got. Now, what I'm going to do is I'm going to plug it back in, and you're going to see a slight difference, which what should happen, the motor slows down. Because at first, what the motor wants to do is pull as much amps out of the battery that it can, right? So it wants to pull heaps and heaps of amps out of the battery and stop in about 5 minutes, right? But now you can see that I've set up a feedback loop, because when I switch it back on, she stops running as fast. Okay? So now the system is feeding back to itself, but everything gets very hot. This plug is now very hot to the touch. So I'm going to have to get a better... The wires aren't too hot. The motor's not too hot. The batteries aren't too hot. But this little plug here wants to blow up. But this shoddy diode is retarding the amps that can go through it. So at first it was spinning much faster because it was pulling as much amps as it wants. Now with the shoddy diode in it, it can only pull out so many amps. So the system slows down, right? But if I start pulling more amps out of the actual generator, the system won't slow down again. It's only allowing 15 amps into the motor, right? But I can keep pulling power, right, out of this motor. I can keep pulling power out of this motor, right? And I can pull out up to 3.8 kilowatts before the system slows down and the batteries run out of juice. Do you know what I mean? I don't know if you're understanding that. So it's slows down, so there's less voltage, right? Because I don't want heaps of volts, right? Now it's only allowing 24 volts because it's a 24 volts worth of batteries and 15 amps worth of maximum current can flow into the motor. What you're first seeing when it's spinning really fast is 24 volts and as much amps as the batteries can provide. But adding the shoddy diode stops that. So it doesn't allow all those amps to keep flowing in. It slows down. So this doesn't draw any more amps. It can't draw any more amps, right? And then this, you can pull as 3.8 kilowatts off it before you start draining the battery. I don't know if you understand what I'm talking about. Probably not, right? So it slows down because I've retarded the feedback loop and created a feedback loop, right? That's why it changes. If there was no feedback loop, there'd be no change in speed. But because I've retarded the feedback loop and it's feeding back now, it slows down, right? It can't take 28 amps out of the batteries anymore, right? It can't take 28 amps. It can only take 15 amps, so it slows down, right? So not only does that show you that the system is feeding back on itself and without running it for 24 hours in a video, right? So what I'll do now is I'll run it and it'll probably get really, really hot. So, and I'll show better video later.